So some people are gone right now. Some people are in a place called like Cancun or something like that. Different places. They're going to have fun. So that means that we need to put a secret word in the video. And in honor of Connor, we're not going to put a word. We're going to put a phrase. And the phrase is going to be
Packers
suck. Actually, it's going to be Packers suck.
And they lost.
Yep. So if you see it and you want to get a free treat when you get back, first person to email me or text me or say to me, Packers suck, you can have a treat. And tomorrow we'll do another one, and it will be something different than Packers suck, but it will probably be along the same lines. So, raise your hand if you feel bad the Packers lost. Nobody raised their hand. Interesting. So we are going to end the suspension and begin our math class today. Thank you, Gina. So this unit goes very, very, very well. It's going to be a quick unit. You're going to have a test next week. Okay, you got to flip the turnaround, get it going fast. Trust me, you want this because you want to spend less time on the easy units and you want to spend more time on the challenging units. Get my point?
Yep.
So we're going to knock this one out and get going. Your goal is to be able to graph all sorts of trigonometric functions by the end of this unit. Sine, cosine, tangent, cotangent, secant, cosecant. In fact, tomorrow's the most important lesson of the unit. Anybody going to be gone tomorrow? Great. Awesome. Tomorrow you're going to learn how to graph by the end y equals -3 cosine of 2x minus pi over 4 plus 1. Does that look complicated? Yeah, it does. We're going to make it super simple. Okay? Step by step. Here we go. We want to graph y is equal to sine of x. What does that mean? Well, x is going to be the input or the degree or the angle that you are trying to take the sine of. So the angle goes in for x. What comes out for y is the output, otherwise known as the terminal point. It outputs the terminal point. Does anybody remember when we determine the terminal point, does anybody remember which value is sine? Is it the x value or the y value?
Y.
The y value of the terminal point is what we're going to output. That's what that means. Okay, so we're going to go to our unit circle, the circle of life, the thing from which all trigonometry derives, and we're going to look at some important spots on that unit circle. What is the first coordinate that I plotted there?
1, 0.
It is 1, 0, and then we have 0, 1. We have -1, 0, and we have 0, -1. And we're going to actually take a full trip around the circle. How many degrees is one trip around the circle? 360. We are going to be working in radians all the time in this unit. So in radians, it would be what? So I'm going to mark off 2 pi. I'm then going to divide that 2 pi into 4 parts. Anybody know why I'm choosing to divide it into fourths? That represents the 4 quadrants. You okay?
Yep.
That sneeze didn't fully come out.
Because I plugged it.
There's just always a chance if you plug the sneeze that your eyeballs pop out.
I've heard that a lot. And have my eyeballs ever popped out? No.
So
yes. Or they see your brain will explode.
yeah.
Yeah.
So I'm the same.
I can hear.
Do you always block your sneeze?
Every single time.
I do too.
But then that means, so I never sneeze in increments of 1. It's always 2 or 3 because my first sneeze, I don't get my germs out. So my body keeps sneezing.
I never do 2 or 3, but I always do block mine. And my people always, why do you do that? Because if I didn't block it, there would be a disaster in front of you right now.
Yes.
Yeah.
How do you keep it in? If
I
you
know.
Don't plug it.
Yeah.
My mom tells me that all the time, and
yeah.
would you rather snap you everywhere?
So you're one of the first people I met that blocks your sneeze because I've done that my whole life, and it's just yeah, I got you. Okay. And I'm going to go up to 1 and down to -1. And so I need to start looking at the terminal points. We're not going to do every single terminal point around the circle. We're just going to look at 3 more of them right now. And the first one is going to be for an angle of pi over 6 or 30 degrees. You may remember what the terminal point is at pi over 6 or 30 degrees. Thank you. In my mind, I'm thinking that every single person here can do that as quickly as pi Ty can. And if you can't, I understand. But in the perfect world, I'm like, oh yeah, everybody knows that quickly. I know that everyone knows this super quick. The 45/45 will produce. No.
Square root of 2 over 2, square root of 2. Oh, shoot, not bad.
That's all right. Axel, we thank you for the confidence in your remark. Everybody go to the root of 2 over 2? Okay. And one more, we'll do the 60, 30, 90. And what point will that produce, Axel?
Square root of 3 over 2.
Square root of 3 over 2 and 1/2? Or 1/2 and the root of 3 over 2?
1/2, then square root of 3 over 2.
Yep. 1/2 and then the root of 3 over 2. Everybody okay with those pieces? The suspension about the graph is killing us right now, so we're gonna end the suspension and figure it out. Okay. So here we go. We start with the sine of 0. The sine of 0 is the y value, which is 0. The y value is 0 right there. Let's move on a little bit. We'll move to the sine of pi over 6, or 30 degrees. The sine of 30 degrees is 1/2. So at pi over 6, which is less than the pi over 2 spot right here, we'll move up to 1/2 a unit. Then the sine of 45 is going to be root 2 over 2, which if you were to compute that as a decimal, would be 0.7071. Be right about there. Then I have the sine of pi over 6, so root of 3 over 2, which is about 0.866. And finally, I have the sine of pi over 2. And everybody here knows what the sine of pi over 2 is. Sine of pi over 2 is 1. And that's the most time we'll spend on evaluating anything like that. We're just going to give you a general idea. We're going to try to now use a pattern in order to see the rest of it. The more you notice the pattern during the unit circle, the better off you're going to be. What's going to happen as we transition into quadrant 2?
Negative.
The y values are going to remain positive, but they are going to go down. Yeah, they're just going to catch the values the same way down, right? And then when you get to the third quadrant, the y values are going to turn to negative. And what's the lowest value that they're going to get to? -1. And then in the fourth quadrant, they're going to start to go back up, right? So what's going to happen is it's going to do that kind of thing. What shape does it make? Yeah, it makes a wave.
What's that called?
Yeah, it's called a wave. It's called a sine wave. Very applicable. What are things all around us all the time that travel like waves? What's that? Radio. So sound, frequencies, light, tremors, they all travel like waves. In fact, absolutely fascinating. So, for example, suppose that Max ends up deceased tomorrow, okay? He is murdered. Everybody say, oh. Oh. Max is deceased, okay? We're very sad about it. We are. And we check his phone because that's the first thing you do, right? The person dies, we look at the phone so you can try to figure out, like, who is, like, hating on him and stuff, sending him horrible messages. And so we find there's a voicemail, and there's this voice on the other side, and it says, Max, I'm going to kill you tomorrow. And it sounds eerily similar to Ty. So what we can actually do is we can have Ty, we can bring him in, and instead for a lineup, we bring him in for voice analysis. We say, Ty, you're coming in for voice analysis. And then he speaks, and we actually come up with a sine wave of Ty's voice. And then we take the recording on the voicemail, and we do a sine wave of that. And if they match, we know who the killer is. Point to the killer, everybody. There we go. It's over. It's over. There's no hiding, dude. Okay? So forensic analysis actually uses this stuff. This happens all the time. I had a really cool one. I'll end with this. I have so many stories about it. I have a friend, she had a really bad brain tumor. Really bad. The good thing was that it was, although it was getting bigger, it was not benign, meaning it wasn't spreading, okay? And it was kind of more towards the central part of the brain. And so it wasn't as simple as like, well, we'll just cut that section of the brain out to remove the tumor. Okay, she would have been really, really hurting if they had to do that. So they had a laser, and a laser is simply light of a different frequency, right? So they had a laser, and if you would take that laser and point it at the tumor, it would like burn a hole through your skull and eventually through your brain before they get to the tumor. So what they did is instead of doing one laser, they did 140. So they have this apparatus. It screws to your skull. Okay, so this large apparatus, it screws to the skull, and then they put 140 different lasers on it that are all they're not very intense. They can actually pass through the skull and pass through the brain without hurting anything. But when they all meet together at one point, they intensify and got rid of the tumor. You know what I mean? So, but in order to make that work, you have to have the right frequency, and it's the right sine wave. There's huge applications all across the real world of mathematics. So the wave is really important, and we can actually predict how it goes after that. It's going to drop down and come back up and drop back down. It's just going to continue on in that pattern, and thus is the sine wave. That's as extensive as I'll get into any introduction to these shapes. The next one we're going to do much more quickly. We're going to do the cosine graph. If you notice the cosine graph, the x value is again going to be an angle. And does cosine produce the x value or the y value for the terminal point? It produces the x value. So we have the terminal point. Now we're going to go once around the circle, so we are going to mark off again 2 pi, pi over 2, and 3 pi over 2. And again, why do I divide it into 4 parts? Representing those 4 quadrants of 90 degrees. I'll put the same negatives. It is the case during this unit that you do get tired of drawing the marks and labeling them. It is something that you will continue to do throughout the unit. So I looked ahead at what you're asked to do on the AP Calculus exam, different things. It is important to know those markings, so we're going to keep that. We are going to go to a value of 1 and then down to -1. And instead, at this situation, sorry, I'll let you guys kind of finish writing that down. Like the orange today.
Thank you.
Okay, so we're going to visualize this as opposed to looking directly at the unit circle. And you want to be able to visualize this in your head a little bit. So if I start the cosine of 0 right here, what's the x value at 0? What's the x value at 0?
1.
1. Everybody agree that this coordinate out here is 1, 0, so the x value is 1? Everybody agreed?
Wait, what are you like?
So I'm referencing what you got right here. If you went out to that spot, that dot, you have the coordinate of 1, 0 right there. Okay? So we know that the x value is in fact 1. So it starts up here. Very different than sine in that it starts up top. Let's advance 90 degrees. What's the x value here? 0. The coordinate is 0, 1, right? So the x value is 0. So we go to 0. Let's advance 90 more degrees. We advance here. What's the x value over here?
-1.
-1. I advance down here to 270 degrees. What is the x value down here?
0.
0. And then as I advance all the way back to 2 pi, what is the x value over here again? 1. And notice that you can produce, that's enough for us to be able to draw the shape accurately. It makes another wave. But I can produce the other values on the other side. Notice the pattern. If I'm up at 1 here, where is it going to be at -pi over 2? Am I going to be at -1 or 0? 0. And then if I continue that same pattern, am I going to be at 1, 0, or -1 for -pi?
0. -1.
-1. And then where do I go after that? 0. And after that? 1. Now go ahead and draw your best wave. As you draw that wave, go ahead and look at your partners afterwards and decide who's got the better wave and is one of them rather embarrassing. So does somebody have one that's like, that's just an embarrassing shape? I'm going to come around and look around. There you go.
That's embarrassing.
At first I took it
Mine's
down.
weird. Mine's like
I fixed it, so it's like a W.
Okay. All right.
Yeah, mine's like sharp.
Jenna's is very good.
Mine's a little like.
I like her suspension.
Yeah.
Oh, suspension.
Okay.
Suspension, I can't take it.
I would appreciate it if we tried to avoid this for our shapes. If you could avoid that, kind of doing the mountaintop peak thing, if you could try to avoid that, that'd be good. Are we good with that?
Yep.
Okay, so let's go ahead and sketch some of these graphs right after we talk about the important elements of both sine and cosine. Over the interval of -2 pi to +2 pi, what is the maximum value that both sine and cosine achieve?
1.
1 is the maximum value that both sine and cosine achieve. What is the minimal value that both sine and cosine achieve?
-1.
They achieve -1. The amplitude is the distance from the middle to the top or the middle to the bottom. What is the distance from the middle to the top or the middle to the bottom? 1 unit. So the total distance from top to bottom is 2, but the amplitude is half of that, okay? The period is how often it repeats itself. If you notice, it takes, so cosine starts on top, and how many x values does it take before it gets to that spot again?
3. 3, 4, 5.
Which is a total of
10 pi.
2 pi.
2 pi. Once around the unit circle, and it repeats all of its values. That make sense? Once around the unit circle, and it gets to all of its values. So the period is 2 pi.
Always?
No, we are going to switch it all right now. But for the parent function is 2 pi. Okay, we good? Okay. All right. So, what we want to do today is focus on what happens if we change a and b. So, for example, if we had y is equal to 4 sine of 2x, what does that look like? Or y equals -3 sine, or cosine, sorry, -3 cosine of pi x. What does that graph look like? And when we do those type of transformations to the graph, that's going to change the amplitude and the period. The amplitude is always equal to the absolute value of a. So if you look at the number out front, just take the absolute value of it, and that tells you how high or how low it goes from the center. That's the same for both sine and cosine. The period is 2 pi by nature, but you then divide it by the b value. So whatever sits in front of x, that is what tells you what the new period is. Okay? So the period can change depending on the number in front of x. And as far as graphing sine and cosine, the steps are pretty easy, but we just got to kind of figure out where they start. So as you look at the sine graph, does that start, if we think about it has maximums, it has minimums, and it kind of has the middle. Does sine start at the maximum or minimum or middle? Look at your sine graph. It starts at the middle. Okay? And if you look at the cosine graph, where does that start? It does. It starts at the max. All good with that? Okay, let's flip it over. We're going to get rid of that page altogether, and we're going to move on to this page. I did look through your homework. I actually got rid of about 10 problems from last year. I don't ever try to give you busy work. I try to give you something that is really going to help you. Within the notes right here, we could get rid of that one and that one. We'll be doing the others to prepare you for this piece. So, and I'm actually going to change this one. Instead of negative sine of x, I'm going to make it negative sine of pi x. That's what we're going to do, okay? So we're going to start with this one right here, 3 cosine of x. We're just going to sketch that graph. And all you're going to do today is identify amplitude and period. Amplitude is the absolute value of a, which will be what?
1.
3. To find the period, you take 2 pi and divide it by what, Nevaeh?
1.
1. Because 1 is the number in front of x, and so you therefore get 2 pi. So again, amplitude affects it vertically. That's the number out front, whereas the period is affected by the number on the inside. That's the horizontal change that we have. So because I have 2 pi, I will mark off 2 pi. I'll divide it into 4 parts, which would be pi over 2, 3 pi over 2. My son wants burgers tonight. My daughter wants chicken.
Oh.
Who's going to win?
The daughter.
Yep, we're doing burgers tonight. We're going to do chicken on Thursday. So
So your daughter didn't win. So your son won.
what did my son want?
Burgers.
My son wanted chicken. My daughter wanted
Oh.
burgers. My bad. And I'm going to go up and down instead of going to positive 1 and negative 1. I'm going to go to positive 3 and negative 3. Okay? So this is how it goes. We see that the cosine of 0 is 1. The cosine of 0 is 1. But then it gets multiplied by 3. So this one is not going to start at 1, but it's going to start up at 3. And once you figure out where it starts, it's very simple from there. I just advance and make my dots. So if it starts up at 3, when it moves over to pi over 2, it's going to cross at 0. And then at pi, it'll drop down to negative 3. And at 3 pi over 2, it'll be back at 0. And at 2 pi, it will be back up at 3.
How do you know that? Yeah, how do you know where to place the dots? How are you getting that?
So wait.
So I'm just looking at the pattern that developed right here. So notice that for our cosine graph right here, come on, our cosine graph started at the maximum, and then it went to the middle,
Oh, so we just look at.
and then went to the bottom, and then went back up. So it just follows that same pattern.
So they're always gonna look like that, just
They're always going to have a wave shape.
It
Yep.
just depends where they start.
Yep. We just got to figure out where they start.
Why would it start negative?
We'll do that example.
Okay.
Yep. So there we go. So I'm going to go back to the other side and fill those in. And there I have that graph. That's actually a really accurate cosine graph. If we were to put that on the calculator, you would be like, wow, that's just about identical. Are we okay?
Yes.
All right, then the next one, what is the amplitude for this one right here? 1, yep, the amplitude will always be positive. It will always be positive, never be negative. And the period is 2 pi divided by pi. What is 2 pi divided by pi?
2.
Dos, which is Spanish for 2. So instead of marking out of 2 pi, I mark off 2. So the x values don't always have to have a pi attached. So after 2, I write 1. And then I write a half, and that third tick mark will be 3 halves. So go ahead and make your x-axis. And since my amplitude is 1, I'm going to go up to positive 1 and down to negative 1. So, Vea, what is different about this one compared to the one that we already did?
We're finding the sine, so we're doing the y.
Yep, we're finding the sine, and this one has what out front?
A negative.
A negative. What does a negative outside do to a graph? It creates a vertical flip, agreed?
Mm-hmm.
So notice the sine graph, it starts in the middle. It's going to start right here in the middle. And it would normally head up. But because the vertical reflection is happening, instead of heading up, it's going to head down. So then we just continue our pattern in that direction. It's going to start by heading down. And then it needs to come back up through the middle. and then it's going to get to the top. And then it's going to come back down to the middle. And once you have that start, you can produce the rest of the graph all the way through. Okay? All right, you're doing well. I would like you, real quick, between you and a partner, I would like you to decide how is this one different than that one. Talk about what makes this different than that. If we were to graph it, how would they look differently? Take about 30 seconds, talk to the person next to you. Go.
Wait, Mr. Gibbs. So how come it looks like that and then we just
Yeah.
Well, this is a sine graph that's positive.
And
So
then
it starts
they're
here and
even.
goes up.
Well, this because you like divide it there and here.
This is a sine graph that's negative.
But like how come the dots are on those and they're not like that on the other one? Like how come they're right here?
So here I produced values for pi over 6, pi over 4, pi over 3. Here we're just producing values for, we don't need to do all of those.
Okay, so that's just an example.
Yep, that's just kind of show you how it works, okay? All right, so I would hope that you would have said that the sine graph, the first one looks something like that, okay? And then this next one would be flipped upside down, but this one would repeat itself twice as often, right? Twice as often. So that means, agree that that's the spot that marks a full period for each of those? So like there's a full period here, there's a full revolution. So this one would have to do 2 of those by that time. So it would have to go down and up and down and up and down. So this one, I went too high. It shouldn't go quite that high, but the idea is it gets twice as many revolutions in. Okay? I'm going to erase that and then try to draw it so I don't. All right, bad job, Mr. Gens. We'll try again. Talk about how this one's different than that one now. How is that one different than that one? Okay, go ahead. 30 seconds, how are they different?
Well, it would be
The
opposite and it'd be taller because
The period is the same for.
So it'd be like that.
Yeah. 4 to 1.
Yeah, it was, because this.
So how high?
Oh, yeah.
Okay, if the first one looks like that, the second one should be flipped, but should it be taller or wider or compressed? How should it be?
Taller.
4 times as tall, right? So this one should like start like 4 times as high and go 4 times as low, right? I mean, this could be significantly different like that, isn't it? Okay, so understand the differences in how they're being shaped. Very common for on the ACT exam for them to give you an equation and ask how it looks different. So we're going to use that for our last example, but before we get to our very last one, I want to do one more involving cosine and a negative. What is the amplitude for this one? 2. And the period, I take 2 pi, and what do I divide it by? What is the number in front of x? 1/3. Does everybody agree that when you divide by 3, that's the same as multiplying by 1/3? So I'm dividing by 1/3. And how is it that I divide by 1/3? I multiply by 3. So I'm going to multiply by 3 and I get 6 pi. So 6 pi is our period. That was embarrassing. I take the 6 pi, divide it in half to get 3 pi. That was more embarrassing. And then half of 3 pi is 3 pi over 2. Sometimes people struggle to pick up the third tick mark. The third tick mark is always 3 times the first tick mark. What's 3 times 3 pi over 2? 9 pi over 2. And then we could copy that right on the back side here. So I told them in their class I was making burgers tonight. And I said I'll probably make French fries with it. And they were like, you make French fries at home?
We do.
I said, yeah. And
Yeah.
how do you do that? I'm like, I buy a frozen bag from the store, put it in the oven. Like, oh
Have
wow,
you ever
that's
cut
fancy.
up potatoes and made them?
Yeah, I've actually done that before, and they're
so
okay. But
good.
yeah, but I like. Does anybody ever have like the frozen French fries at home?
Put them in the air fryer.
Yeah.
Yeah, it's like it's not, I mean, that's not too fancy. I just
No.
figure. So I
That's
feel
normal.
it was easy. Tell Zizi she needs to have more
Just have
French fries at
fries
home.
at
Yeah,
home.
yeah. So, all right, I'm gonna mark off 1 and 2, -1, -2, and this is the cosine graph. So remember, cosine likes to start up at the maximum. But if there's a negative, what's that going to do? It's going to flip it to start at the minimum. So this cosine graph starts down at -2. And where's it going to go from there? It's going to head on up. So cross over 0, get to the top, back down. That's my shape. So the most challenging thing that people encounter in this unit, this will be our last lesson for today, is to sketch a graph of these on the same axes. And that's the key, that they're sharing the same axes. So we're going to see how different they are. And you can tell that they're going to look different, aren't they?
Yeah.
So let's look at the amplitude for each one, and let's look at the period for each one, and then we'll start making our marks. Amplitude for the first one is 2, and obviously the period is 2 pi. The amplitude for the second one is 6. What is the period for the second one?
1/2 pi.
1/2 pi, otherwise known as pi over 2. So as I go ahead and make my x-axis markings, should I put my end at pi over 2, or should I put my end at 2 pi?
2 pi.
Yeah, if I want to see both of them, I should definitely put a marking at 2 pi. And then my y-axis, should I mark it 2 high or 6 high?
6.
6, because I want to be able to see everything. I'm going to mark it by 2s, 2, 4, and 6. 2, 4, and 6. And so that's the structure. Everybody okay with the structure? Okay, so now you decide which one to graph first. And it's my advice that you always graph the one that has the largest period. So since that one's going to be stretched out over the entire distance, I'm going to graph the first one. Okay? Where do I start?
Middle.
Middle. Do I start by going up or down? How come?
Negative.
Because there's a negative. And once I had that, I could just go ahead and take my pattern and move about. And this was the point. Are you good? Okay. This is the point where people got confused during. Okay, yep, thank you.
Why didn't you go back down when you went negative?
Had to do it full way.
Oh,
You mean on this side?
Yeah,
So
because like right here, when you came back down.
nope.
Did I graph down wrong
Yeah.
too? Oh. Okay.
So if I can turn you right here, Bea.
Okay.
Better?
Yep.
Okay, good question. And what you just asked, that is a common mistake that's made sometimes.
Okay,
Okay, so next part is where, this was the part where people got a little bit confused. So I'm going to graph 6 sine of 4x. So where do I start? I start at the middle because it's a sine function. Am I going to start by going up or down? Up. Now here's the deal, folks. I have to complete a full cycle by the time I reach pi over 2. So I'm not going to finish a full cycle by this spot. I finish a full cycle by this spot. So that means by the time I get there, I have to go up, cross over the middle, come back down, and back up. And so that graph, I'm going to do a full cycle between every tick mark. And every once in a while, somebody will interject and talk about how that's not really an accurate graph. That's the graph on the calculator. Does that look the same as what I drew?
Mm-hmm.
Yeah, it's pretty much dead on. So it is an accurate graph. That will help you get through the first assignment. The first assignment is a front and a back. It used to be 3 pages, but I cut some stuff off for y'all. I'm going to hand out your tests.